Oh, God, I guess time to do some wiring. Better get some supplies. Now I'll get my multimeter turned on here and dig into this wiring harness here. Oh, crap, I need my back probes. The hell is that? Alright, got what we need. Well, where'd it go? Huh, well there you are. Come on, come here. No. Whoa! Oh, Jesus! Ah! Ah! Today's episode, T.N.T. Garage. We're going to look into the wiring basics. Let's get to it. Hi guys, welcome back to another episode of T.N.T. Garage. Today we're going to tackle wiring 101. At least try to be somewhat educational here on this channel. So, a lot of people when they're working on cars, they could do all the mechanicals, body work, anything like that, but where they really stumble or are afraid is when it comes to 12 volt wiring, which is what I shouldn't say most, 98% of vehicles run on. Military stuff, it's 24 volt. Big industrial equipment's 24 volt, but we're going to focus on 12 volt stuff. So we got our magic whiteboard here, and we're going to go through some of the just basics to start out with. So when you start with a 12 volt system, of course, you're going to need a battery. So the battery stores your energy. And you're going to have 2 posts on every battery, one of which is going to be your negative, which is your ground, and your other is going to be your power, which will be your 12 volts. Now, a simple circuit when it comes to a 12 volt system is you're going to have a ground wire going into some sort of load. Now, a load is a light bulb, a 12 volt motor, so like your blower fan, wiper motors, anything like that, or your ignition that's run on 12 volts. So we're just going to do something simple, which is a light bulb. So in order to make it light, you need a power coming in and a ground going back. That is a simple circuit. Now when you're talking automotive wiring, where you have an entire car, we're going to leave our light here. So you're going to have the car itself. Please excuse my drawing skills on the whiteboard. So you're going to have your wheels, you're going to have your car. I need to go back to kindergarten. Anyway, so in order for that light to work in your car, you need a few things. You need, from the battery, you need a ground to the chassis. So the body and or the frame. So if it's a Camaro, like what I have right behind the camera here, it's a unibody. So anywhere you attach a ground is the frame. On a pickup truck, it's body on frame. So you want a ground to the frame and a ground to the body from the frame. That way, you know, you're getting a good ground. And then also, you're going to have an engine in there. You know, put some headers on that. Small block Chevy, so you put two together, so you have an engine. So you got ground to the body, and then that ground is also going to go to your engine. Now your power side is going to go through a switch. So a simple switch, which the toggle, you're going to have 3 posts on it. You're going to have a ground that's going to go either into the main ground or most likely into the body of the car with an eyelet and a screw. You're going to have power from the battery into the other post. Now, in order to turn that light on, which is also grounded to the body of the car, you're going to turn this switch. And what happens when you turn this switch is, since the switch is grounded, the power is going to come in and then come through this one here up to the light, and it'll illuminate the light. So that's a very simple 12-volt wiring setup in the chassis of a car, grounded to the body, grounded to the engine. It's pretty simple stuff. So we're going to go through a few tools of the trades to just diagnose a simple schematic like this. So you can use either a test light or a multimeter. I like a multimeter just because you can do a lot of things with it, and we'll get into that shortly. So you're looking at this and you're going, well, I flipped the switch, my light's not turning on. Well, you go in and diagnose it. Of course, it could be a bad bulb. A lot of times it is. So to make sure your bulb's bad, you're going to come in and there's going to be a connector. And you're going to hook your red lead to the power and your black lead to the ground with the switch on. Or you could do it with a test light, just your test light to the power, the clamp to the ground. And what you're going to want to see with the switch on is 12 volts. So you know power is getting through the switch and up to the light. Okay, so you know you have a bad bulb. Well, what happens if you hook it up and you don't have 12 volts? Well, you can go one of two ways. What I always check first is the ground. So this ground wire goes to the body. Well, so what I'll do is I'll hook my power side and my negative direct to the battery. And if I get 12 volts doing that, then you know this ground is bad in the car. And one way to check to make sure it's bad is to, on a multimeter like this, is put it in ohms. It looks like a horseshoe. Ohm, you know, that thing that monks do, the ohm. Kind of like that, except this is a lot more frustrating. So you're going to want to check the resistance. That's what ohms measure, is resistance. So to verify you've got a bad ground, one end of the ground, the other end of the ground. If you have zero resistance, then it's good. It could be the connector that's bad. So that's diagnosing the ground side of a system that's not working. Now, to diagnose the power side is fairly simple. If you don't have power at the bulb and you check your ground to make sure there's no resistance between the ground at your connector and at the body, well, now you can start chasing power. So you know you don't have power here. And you can do two things. You can check the resistance from here to the switch, from the bulb to the switch. And if you have zero resistance, you know that's a good wire. If your resistance is higher or out of limits, which will just show OL, you know this wire is bad. Now, you can also, once you see that that wire is good, you can go ahead and check this for voltage. So you can put your power on here and ground it anywhere on the car. If you have power there, great. If you don't, now you check to where the power originates. Make sure that this wire coming into the switch is good. So same thing, check for power here. If you have power, which you wouldn't if the switch don't work, but you're checking for power, and you can also check resistance between the switch and the positive side of the battery. And that is a real short course on how to diagnose a simple electronic circuit. So we're going to reset our board here, and we're going to dive into fuses and relays. And hopefully, once I'm through showing you all this, wiring will not scare you anymore, because it's just simple. Don't overthink it. Okay, now we have a more advanced circuit, which is what you're going to see in most vehicles. Now what we have here is a battery, a power distribution block, which basically your big cable from the battery, after it goes to the starter, of course, comes up to your power distribution. That is what distributes power. So you're going to have a lot of fuses in there and relays. So you're going to have fuse, relay, switch stuff, and onto your load. Now, say you want to run a blower motor, or like some KC lights, something super bright. That's going to take a lot of amperage, which amperage is the flow of power, how much power you're pushing to any given thing. Think about it as like a hallway. If you have a 2.5 foot hallway, you can fit plenty of people down it, but if you want to get a lot of people down it, they're going to run into each other. They're going to plug the hallway. But if you have a bigger hallway, you can fit more people down it in a hurry. So this is where relays come in, especially with a large load device. The reason you want to use a relay is pretty much load and wiring size. Now, a wire like this, which is about a 16 gauge wire, is meant for light loads. You can run a light bulb with this. You can run accessories with this that just don't take that much power. But if you want to run something big and you try to use this little guy, you could run into fires, or you could blow your fuse because you just can't put that much through the wire. You want to use something thicker like this that's a 12 gauge wire for a large load. So that being said, this is how a typical system works, and we'll learn to diagnose it from here. So you have power coming from your battery into your power distribution block. You've got the battery grounded to the frame, as we talked before, in the body of the car. And you have this motor that you want to work. Say you want your blower motor for your heater to work. Well, in order to do that, you could run a big wire to a fuse, out of a fuse into the switch and directly to the motor. But the problem is most of these switches cannot take that much load. And you don't want power, that much power going through the entire car from the battery to the switch all the way down to the motor. So inside your power distribution block, you're going to have both the fuse and the relay. And this is going to cut a whole lot of large load out of your car. So going into the car, you're going to have a little wire going into a fuse, into the switch, and of course the switch is grounded. Well, how do you turn on the motor if you have the switch in there and nothing going directly to the motor? Well, you have another little wire that runs from the switch to a relay. The relay's job is to take the large load, because they're built to withstand it, and be remotely activated. So you don't have to have all this inside the car. You can just have your switch in the car with little wires going to it, not these great big fire hoses. So what happens is you flip the switch, power comes in and goes out to the relay to a solenoid, essentially, that's grounded. And what happens when you energize this is this arm switch connects the two and supplies power to your motor, which is grounded through a nice big heavy gauge wire. So you're not going to overheat the circuit, and it's remotely activated. You don't have one of these hogs running from front to back. You just keep it under the hood, right to the blower motor, or just barely inside the car. Now, pretty easy to diagnose something like this. It might look complicated, but it's not. If you go back to the beginning of the video, everything I did, you can use right here. So say you don't have your motor working. Well, you could start here and work your way back, or you could simply check the fuse. If the fuse is blown, well, you can replace it, but there's probably an issue lying underneath that's going to bite you. So if fuse is bad, you might have an issue. We'll tackle that in a second. But if it's good, you test for power at the switch, power from the switch to the relay, ground from the switch, and if you have power to the relay, well, now you need to start checking. So you pull the relay out, and you're going to want to check for power here, because your battery comes direct in. If you have 12 volts there, you check for ground to make sure when this power comes in, it's activating the relay. If it does work, your issue is somewhere in here with this wire, either a bad connector, or the wire itself is broken. However, if you don't have 12 volts coming out here on this side of the relay, you can simply take the relay out to test your circuit and run a jumper wire post to post, and if your motor starts running again, you know you got a bad relay. Or if this power is not going to it and you jump it and you look and you see you got no power, well, I got to restore the power. Could be the switch, could be the fuse, could be a lot of things. And some other tools in the trade to help you along the lines here, because sometimes, cutting a wire and getting the end off of it to jump or something like that, you can skip all that crap by getting yourself a set of retractable test leads. I use these quite a bit. If I have a long circuit from the front of the car to the back, I can clip one end to the front and one to the back to bypass the circuit. These things are worth their weight in gold, which I use them, I use it for almost everything. Testing circuits, providing temporary power somewhere. The other thing you're going to want are these little guys. These are probes. So if you're dealing with a switch and you want to see if there's power back there and you can't get the connector off, or you want the connector on to just quick check, a lot of guys do this, and sometimes there's no other choice. Don't just grab your probe and jam it into the wire. Because what's going to happen there is, you could test it, but you're going to leave a hole in the wire. And that's going to allow corrosion to get in and ruin the wire. And then got a bad wire. Now it don't work anymore. So what you want to do is stick one of these guys behind the switch through the back side of the connector. And then you can hook your lead up to it without pushing in the wires or anything like that. These things are awesome. And they're $10 for a pair, or 4. I don't remember. It's been a while. So there's your basic wiring layout, what you're going to see in most cars. Now, something older like the Camaro, or if you have an older vehicle, a lot of times you're not going to have a power distribution block. You're just going to have heavy wires coming out of the harness going directly to a relay that is through a switch also. Now, that explains the basic, most systems in a car run through relays. So your heavy load stuff, fuel pumps, blower motors, windshield wiper motors, stuff like that. Even your headlights are run through a relay, because it's a lot easier to have a short little circuit than to have one the length of the entire car. Because the longer it is, the more power it eats. So we're going to talk about diagnosing why you might be blowing fuses and voltage drop next up. Okay, so Most common problems, which is what scares a lot of people away from wiring, because when the system works, it works well. You shouldn't be blowing fuses. You shouldn't have issues other than, say, a light bulb burning out, a motor going bad, which could blow the fuse because it takes too much power to try and run it. But without diving in too deep, we're going to explain one of the most common reasons why an electrical circuit fails, and that's a short to ground. What does that mean? Well, just what it says. It means you have a short circuit to a ground. So you got a light that doesn't work, and you keep blowing the fuse, and you test the light, and it's good. Well, second you put the fuse in, blows another one. Well, where do you start? Well, it's probably a short to ground. So what happens when a short to ground occurs is usually in a wiring harness, you have many wires running together. Sometimes with those wires running together, going over the road, they start rubbing and wear the coating off, leaving a bare wire. And that bare wire with power could either wear into a ground wire or to the metal chassis of your vehicle. So essentially what happens is before the power gets to the light bulb, it's actually connected to ground. And you cannot run power directly back to a battery's negative terminal, which I'll demonstrate in a second. Now, to demonstrate what happens when you have a dead short to ground and why you cannot run power directly back to itself, we'll show you right here where you take a wire, just strip the ends off, and this is why fuses are good. Well, my wire strippers don't want to work. There we go. So what would happen if I put a fuse in here and I touch these two, it would blow the fuse instead of either burning the wire and starting a fire, breaking the end of the wire off. That is a dead short to ground. So short to grounds means you're sending too much power directly back to the battery. So we'll prove that by watching this wire burn up when I touch this side over here and this one right here. Now, kids, that's what happens when a circuit blows. Don't try that at home. After getting cleaned up and changing my britches, we can get back to our shorts to ground. So earlier we talked about why you might be blowing a fuse all the time and how your power wire is inadvertently touching a ground. This is where a lot of people get frustrated because they're not slowing down and thinking a little bit. So if you have a circuit that consistently blows the fuse and that light's not working, or your motor or something like that, you definitely need one of these, which you get your multimeter out and you check for continuity. Now, what continuity means is you have a steady, unbroken path from one end to the other. It's constant. So you're going to want to check that circuit. Now, if you keep blowing a fuse, the first thing to do is pull the fuse out and take your two leads, and you're going to hook one lead here to the power out to whatever, the switch, the light, anything like that. So you're going to run that, and then the other to the battery ground. And what you do or don't want to see when you're doing that is if you keep blowing that fuse, and if you see this, you have other problems. The fact that it's just showing a 1 and nothing else means there's no continuity to ground. However, if you touch one end to the output side and one to the battery, and you see that, that means you have continuity to ground, which means you have a short to ground. Now, there's a few ways to fix this. You can either go down the wire, disconnect the wire and put a new wire in from the fuse to the load, or you can work your way through the wiring harness and find if a wire is chafed to where you have it touching and replace that section. Now, when you go about wiring repairs, there's a few things you want to keep in mind, and that's doing a proper repair. So I'm going to grab a couple tools that you want to use to do this. All right. So now, if you have to repair a wire to repair your short to ground, you're going to want a connector kit, and you're going to want heat shrink tubing. Now, heat shrink tubing is something that you simply put over a wire when you connect the two wires. After you connect them in, put this in, and say you slide a connector on the end after you trim the insulation off the wire, crimp it in, slide this over it, over both sides of the wire, and you heat this up, and this creates a weather-tight seal in your electrical connection so you don't get water intrusion and corrosion. Now, they do make these that are heat shrink. There's a couple problems with those, and this is why I would rather, on this car at least, not use heat shrink connectors. Because this is another thing you're going to want. This is a crimping tool. This ratchets to crimp your connection. So it puts a nice little crimp in there. And that's what holds your wire tight in the connector. The problem with heat shrink connectors is most people do not crimp them with the proper tool. So what happens is they split the actual insulation itself, and that allows moisture to get into the center. Then you have an electrical issue. So if you use a regular connector and some heat shrink tubing, you are way better off. And what I'm going to do in this car is, I don't like these insulated terminals because, number one, they're pretty bulky. I don't want a whole harness when I'm joining two of them full of these. But the nice thing is you can make this an unshielded connector. So you just take something to stick in here and you drive it onto the table, and you can actually drive this out. Some smaller tool here. There you go. Now you have an unshielded connector that you can go ahead and put your wires in and crimp it and slide your heat shrink over. It's a much smaller connection, and it'll still be secure and corrosion free with a quality heat shrink. And that's how you want to repair the wire. Can you use the heat shrink connectors? Absolutely. Just use the right tool to do them, and you shouldn't have any issues. They are bulky, but they do the job. So that is your short to ground. Now, we're going to take you on a journey. And this is when weird stuff starts happening in your car. And this is where people either sell cars or, oh my God, I need to replace the whole electrical system. No, you really don't. So, this is a weird one. A short to power. Now, what's that mean? Well, that means you have power going into a circuit that you don't want power in. So, to kind of explain this better, we'll have a switch here just so I can better explain what a short to power is. Now, a short to power typically does not blow fuses. It just makes weird stuff happen. And weird stuff is if you have this switch off, but that light's still on. Why is that light? I turn the switch off, but the light's still on. Well, here's the problem. Same thing. You've got a wiring harness packed with wires, and you start getting them rubbing together, and now after the switch, so between the switch and your load, you're got another wire right next to it powering something else that has now rubbed into your other power wire and providing power past the switch and illuminating a light or a motor still running when you shut the key off. That's a short to power. So there's a few ways to test this, of course, is to take your multimeter, again, put it on the ohm setting to check resistance, and you can test with the switch off from your load, light bulb connector, blower motor connector, anything like that, to the battery. And if you have continuity, you know that you have a short to power. And you see this a lot, actually, in commercial vehicles, especially with an incandescent light. So something that's not LED, it's got, like a 4-inch round light that's physically got a light bulb in it. And what happens in one of those, if you have a light that's, say, stop, tail, turn, you're going to have two filaments. So a little filament there and a big filament for your brake light. Sometimes what happens is these, from so much vibration, will break and they'll drop onto the little filament. Now, is it something that could cause a fire? No. It's just something that baffles a lot of people. So what happens when the filament breaks or you have a short to power, if two wires touch, is once you load that other circuit, so we'll do a quick diagram here. So this goes to a switch to turn your parking lights on, and this is your brake switch. So when you have a brake and two touch, you got the lights off, and suddenly when you hit the brakes or turn on another load and something else turns on, it's where these are touching. So sometimes in a truck with these 4-inch incandescent lights is once this drops, you'll hit your brakes and turn your turn signals on and your parking lights turn on or flash with the turn signal. That's a short to power situation. Not as common as a short to ground because there's a lot more ground on a car considering it's metal and there's fewer power wires running through. But a short to power is definitely something that really drives people up the wall. Like, why is this accessory still on when I turned it off? Well, there's your answer right there, is a short to power. And again, most techniques you use is you're checking for continuity. So let's go into our next segment about voltage drop and dive a little further into continuity. Now we're going to talk about continuity and voltage drop. And this is where a lot of people have long given up. And it's actually not that bad. Just bear with me. So continuity, we've talked about before, is the flow, the constant flow, and the zero resistance of any given circuit. Voltage drop can cause a litany of issues, and this is where a lot of people check out when it comes to wiring. But trust me, once you know it, it's not that bad to figure out. So we've got a very, very, very basic circuit. Power to a motor to a ground. Of course, the battery is grounded to the chassis, the motor's grounded to the chassis. Continuity, you may, and I'll prove this right now, you may have continuity in a circuit and have zero resistance. But that motor is not working the way it should. So what I've done here as an example is we're going to strip this wire, and just to make it easier for me to do with both hands, this is where these come in handy, is I'm going to go ahead and I'm going to connect this wire and show you why sometimes you might have good continuity but still not have a completely functioning circuit. So we're going to use the red wire here because I smashed the alligator clip on one of my green ones. So we're going to clamp that securely on both ends of our red wire here in our test leads. Now, what I have done, and I don't know how well you guys can see this in the camera, is I have stripped the wire and just got one strand. That's it. Just one strand sticking out. Now, what's going to happen here is I will take our black leads and clamp these together along with our test leads of our multimeter. Yep. Big fat hands don't really help. We'll skip the leads. We'll just touch this together. There we go. Make sure I'm not touching everything. Now, just these two strands connected, we've got perfect continuity. There's zero resistance. Now you might think, well, you got zero resistance, everything should work, even though it's just going through one strand. Well, the problem is, this is where a voltage drop comes in. If you're trying to push voltage through a 12 gauge wire like this one is, and you only have one strand connecting it, you're not getting the full voltage from your source to your load. So there's a few things that could happen. You could have a slow motor, like a blower motor. You could have a dim light, and that's because you might have good continuity, but you've got voltage drop. And the way you check for voltage drop is you go ahead and you put this in your DC voltage setting, which is direct current, which all 12 volt systems are automotively. And you're going to check at the battery what your voltage is, which, say at the battery it is typically, let's say 12.4 volts. But you get to this end and you check with your leads there to your battery ground, and for some reason you only have, say, a good voltage drop, even if you're just like 11.9 volts. That could potentially slow it down, although it could be a lot lower. But I'm just using these as examples. So not having a full voltage to this motor is causing it to not operate properly. So what you're going to want to do once you see a drop like this is you want to check the wire. Now you can grab a set of test leads like this, clamp one end of the battery and the other end to the positive side of whatever load, your motor, your light bulb, and if it starts working properly, you know this wire is bad. And there are several ways of detecting where in the wire that it is bad. You can get a power probe that allows you to work down the wire and determine which area of the wire is bad, or you can simply replace the wire. Which, if you have one bad spot in the wire, chances are is that you're going to have several down the road. Now what happens if you test this and it's not working right, and you end up from here to here, from your load to the battery ground, and you still have 12 volts, it's still not working properly. Well, what you do then is you go from here to the ground coming out of the motor. And if you get a drop in voltage at that point, you know you have a problem with your ground wire, where you may have good continuity, but you still have a voltage drop, which means your wire is not properly carrying the voltage away from your accessory. Now, the other thing that will affect continuity is corrosion. So say you're going and you're testing everything and it's not working right, but you don't have any voltage drop. You got 12-4 at both ends with both grounds, and it's not working right. Well, you check your continuity, and if you're not zeros across the board, or if you're something that's out of limits to spec, say if it should have up to 1 ohm of resistance and you've got 5, well, you're not getting the amperage then to the motor to allow it to work efficiently. And typically that is caused by corrosion. Nasty corrosion. And what corrosion will do is it encases the wire and starts breaking down the copper itself. So it's basically a roadblock for your voltage and amperage getting there. So typically that's what I was talking about when you back probe a wire or just jam your lead in there. You can get corrosion inside of it, and it starts turning green and nasty. And the same thing what I said earlier with heat shrink connectors. If you break the insulation while you're crimping it with the wrong tool, you're going to get corrosion, and that's going to slow down the flow of energy from your battery to your load. So all in all, electrical isn't that bad. I mean, this is a very, very simple outline of it, and what your best friends can be when you're looking into bad circuits or anything is to have a proper wiring diagram. Now, most of these manuals, you have Haynes, you've got Chilton, and of course you got the Mitchell manuals. I recommend the Mitchell because they have much better wiring diagrams. But if you open the book and you're looking for a certain system, say this is engine control for the TPI motor was in that car, and you're having an issue with your IAC. It's not working right. You can go into the manual here, and hopefully I'm holding this so you can see it, and you can trace the wires from the connectors, and it has your wiring color listed on each wire and where the power originates from, where the grounds are. These are your best friends. It's a good wiring schematic. And like I said, you can pick these books up at most auto parts stores. You can order them online, or you can go online to like Mitchell or AllData, get yourself an account if you're doing this a lot. If you're a weekend warrior, or a shade tree mechanic, or an ex-mechanic that's doing this as a hobby like myself, it's really not justified to spend $100-some a month on a online subscription. So you can do a month and get the stuff you need for a project, or you can get those books. Now, these books do not have every wiring schematic in it. Like, I need the bulkhead schematics for the Camaro and CK OBS trucks. So I'm going to be getting that through Mitchell and downloading the actual wiring schematics. So hopefully you guys learned something when it comes to wiring, and it's not as scary, because really wiring is simple. You just want to make sure you've got continuity, you've got voltage, you've got the right amperage. There's a couple other tests we could do, especially when it comes to a power draw, which before we go, we'll actually talk about testing for a power draw. Say your battery's dying out of nowhere and you're really trying to figure out what the heck it is. So we'll come back in a second with a power draw and we'll wrap this up. All right, the final thing that we're going to talk about is a power or parasitic draw. This is something that, oh God, a lot of people deal with, especially on older vehicles, is a parasitic draw. So you put a brand new battery in your car and within a day or so or a week, it's dead. And you're trying to figure out, why is my battery dying? Now, this is really something that's simple, and I don't know why a lot more people don't know how to diagnose a power draw. In fact, a friend of mine had a brand new Harley Davidson that the battery died within a week, easily, just die within a week. Took it to shops and they looked at it, but they never did what they were supposed to do. And this is a proper way to test for a parasitic draw. Now, say you've got a vehicle where your battery just keeps dying and it's something drawing power to kill your battery, but you don't know what. Well, this is how you diagnose it. You're going to take your multimeter and you're going to move your lead over to the amperage side. Now, this is fused typically at 10 to 20 amps, depending on what meter you have. So you put it into the amp side, keep your common ground the same, and you're going to put it into the DC amps, which direct current. The main thing to do is you're going to disconnect your positive side of the battery. So take the lead off the battery, and you're going to want to hook one side to the battery itself and the other side to your power cable going to the battery. And you leave these sit like that. You clamp them on, whatever you got to do, and you're going to watch your display. And you're going to see some amperage reading come up. It could be 4 up to 20 amps, and if it goes above that, well, you blew the fuse in your multimeter. But unless there's a blower motor running, you're not going to blow the fuse in this. And if it's a small enough draw, you're safe to do it. So you're looking at this, and you're looking at an amperage draw. Say you got a 10 amp draw. Well, once you get these hooked up, what do? Well, you're going to go into your power distribution block or your fuse panel. And you're going to go, and this is a tedious process, grab a pair of needle nose, whatever tool you got to do, and one by one, you're going to be watching your meter as you pull a fuse. Pull one fuse, look at your meter. If it didn't change, that circuit's not your issue. Put the fuse back in and work your way through the fuse box one by one, pulling a fuse, checking to see if your amperage changed, and replacing it before moving on to the next one. And you'll work your way through, and eventually you're going to pull a fuse and your amperage drops to 0 or close to 0, because there are some systems in cars that require a constant amp pull, but it's very minimal. So if you watch your amps drop dramatically when you pull a fuse out, you look at what that fuse came out of. Say it's a power window circuit. You pull that fuse out, your amperage goes to 0. You know on that power window circuit that you've got a draw. Now that could be a sticky switch, which is causing a motor to just sit there and slowly try to turn. It could be several things, but you have a starting point then to know which circuit to go through and see if you have a short power, or if it's trying to ground itself will cause a parasitic draw. But that's how you determine which circuit is causing your draw. So you hook up your multimeter to the battery after you disconnect your positive lead, and then you hook your multimeter again to the other side. You do not want your positive lead connected to the battery. You want your multimeter in between. So hopefully that wasn't too complicated as far as determining a parasitic draw. It's actually a lot simpler. It's just time consuming, but you will find the issue doing it this way. So there you have it, guys. Hopefully we had a little fun today. Hopefully you guys won't be as afraid to tackle any wiring project in your vehicle. You know, there's a couple things to consider is wiring gauge, you know, fuse size, and how you're going to wire up extra accessories. But hopefully this gives you the baseline to not be afraid to diagnose your own electrical system instead of booting the car down the road or paying someone else big money to diagnose it for you. So thanks for watching T.N.T. Garage. I hope you had as much fun as I did today, and we'll see you again.